Okay, so now we're actually pretty close to having almost all of the naming we need. Okay, there's just a few things that's left. So this is going to be the naming of compounds where the functional groups calls for a suffix. Things like alcohols, amine, ketones, aldehydes, carboxylic acids, and carboxylic acid derivatives. So here we have the same root, prefix, suffix that we've been talking about before. Everybody's okay with that? Okay. Okay. Before we had mostly ended up doing things like chloroalkanes, that sort of stuff here, right? And then this had been your main chain. You're all good with that. And then this part had been the suffix, things like ene, ein, enol, right? Okay. So now we're going to be getting into, and I had hinted at it before, you guys had asked me before, and I went, there's going to be a list, and we'll have priorities for which ends up being the suffix, right? Now we're going to be getting into that because I'm going to be giving you those last few functional groups that are common, okay? Now, please do note there are functional groups I have not given you yet, and I will not give you in this 2-semester rotation of organic chemistry, okay? They're incredibly rare. You don't see them a lot. And if you need to use them, frankly speaking, you're probably a master's or PhD anyways, and you can figure it out, okay? You're already far enough along you can look it up, right? You'll be fine. Just deep breaths. The rules are still the same. You just got to figure out that new functional group, okay? All right. So we're going to determine the highest priority functional group that's present. We'll establish your main chain or ring. The main chain or ring must contain your highest priority functional group. That was what was going on with those double bonds, remember? Where we had to put them in the main chain or ring. Okay. We're adding the appropriate suffix. You'll choose the suffix that corresponds to the highest priority functional group, and that'll end up being your suffix. You'll remove the E from the normal ein, ene, ein ending. Then you'll add the suffix to those. Now note the ein, ene, ein, those end up not being true suffixes. Okay? Those are actually part of the root. Does that make sense? They're part of this part. That's where the ein, ene, ein goes. That's why you got things like enol, einol. Those were actually part of the suffixes, the en and ein. Okay. Nitriles are an exception to this, by the way. That's going to be an exception. It happened again. Don't you love it when your chemistry professor goes, except for this thing? You'll number the main chain or ring. You're going to add locator numbers for the highest priority functional group. Then you'll add prefixes and the remaining locator numbers. And these are just going to be minimizing the numbers that you give them and doing them in alphabetical order, okay? Just like before. But remember, the highest priority functional group always obtains that first numbering. And oftentimes ends up setting your numbering for everything else. That was what was happening whenever we were doing those benzene rings. Remember that? We were doing the benzene ring, benzoic acid, etc. And we were putting those suffixes on there. Those were always number 1. And then they were setting the numbering for everything else, weren't they? Okay? And so you've already actually kind of done this before. We had not explained the priority of functional groups before, but you had been using the priority of functional groups because we didn't have enough functional groups to actually have priorities. So, yeah. Okay, so these right here are your common functional groups. These are the priorities for those functional groups. See the numbering, 1, 2, 3, 4, 5. Like so. This table is in your book. It's also in my PowerPoint online if you are looking for it. And so what you will notice about this priority is it kind of mostly follows in terms of the electronegativity or oxidation number. Can you see that? It basically follows along with the more oxidized the carbon is, the higher priority it is. You see that? Okay, so when I was learning this, I did not bother trying to memorize all of these. I think I told you the story where my professor was giving me a test every week, 6 pages front and back mechanisms. I did not have time to memorize things. And you can get away with it surprisingly well because it really, really closely follows basically oxidation, right? Here we have the carbonyls. Everybody sees that carbonyl, okay? We have the carboxylic acid. This is the acid anhydride. Anhydride meaning what? An means without. Hydride means? Yeah, specifically the negatively charged hydrogen, right? Yeah, anhydride. This right here is your ester. Everybody's familiar with esters, right? Ester linkages. Yeah. Okay. This right here is your amide, as in amide linkage. Notice the acid chloride is here. That's the carboxylic acid derivatives, by the way. That's one of those. In fact, these are all carboxylic acid derivatives right there. Those three. This right here is nitrile. That is one of the exceptions. That's the weird one. Okay? And then this right here is your aldehyde, ketone, alcohol, amine. You'll notice that this is not completely exhaustive, but this is the most common ones you're going to run into. Okay? If you had to do something that was not listed in here, then you would have to look that one up, okay? Okay. Mm-hmm.
What was it you said? How you sort them? It was based on
the number.
Well,
the overall pattern is oxidation.
oxidation.
Yeah. It's kind of hard some places in here to figure out which one's more oxidized, like the acid anhydride. But overall, the pattern, oxidation numbers. Okay.
Why do aldehyde and ketone have the same prefix?
Which one?
Aldehyde and ketone. They were prefix.
Oh, because it just matters the position. This is end of chain, middle chain.
I feel like that'd be confusing. Not completely the same thing.
It ends up being surprisingly not mattering. Because basically what happens is this is either 1 or the last number in your chain. And this is just every number that's in the middle. Yeah. And so when you actually write them out, it ends up not mattering at all. If they would have made another one, it would have made it easier to find it like a second faster. But then you would have had to memorize an extra prefix, right? And yeah. Yeah, it ends up not really mattering much. Surprisingly little. Yeah. Yeah. But the others technically matter more. You'll notice that the esters are actually a pretty interesting and weird one. Yeah. These ones down here that are the carboxylic acid derivatives, those end up being kind of an interesting one. Very reactive, very weird stuff. Okay. Okay. And so let's talk about naming alcohols and amines. The main chain or ring is identified for these. The E from the normal ane, ene, ine root name is going to be dropped. The OL suffix is added to indicate the alcohols. Locator number is used when necessary, and the highest priority functional group is given the lowest possible number. In the examples here, we only have the one OH, and I think everybody's mostly comfortable with these, right? Okay. Please note that you're going to be using the new IUPAC. I don't think the old IUPAC is basically ever used, except for old publications now and people that are really, really stubborn. Even though I hate the new IUPAC. Fair enough. All right. Does anybody have any questions on these names? Okay. Why are the numbers here always 1 here, 1 here, 1 here? Yeah, the OL is the highest priority, right? The OH is their highest priority. Why is this 2? Yeah, we can't put a 1, right? We couldn't start the numbering and do a continuous chain that way. Yeah. Okay. Here's the amines. Again, same sort of rules. Notice that the amines are higher priority than the nitro and halo groups. And so the amine takes priority over, for example, that nitro group there and the halogen right there. Okay. Anybody have any questions about those so far?
So with the 3-nitrocyclopentanamine, you don't need to, because the amine would have to be 1. You don't
Exactly.
have to specify.
Yeah, if the suffix is going to be 1, you can actually get away with not specifying.
Okay.
Theoretically, you could have actually just done propanol here, but because there's a 1-2 positions that are possible for that propanol, it's good form to put the 1 for the propane 1 all. Okay. In this case, the rings here, you can't do any position other than 1.
Could only be 1.
Yeah. So you don't have to put them at all, and that's not a form thing. It's just, it'd be a waste of time to put them. So you will see that if it's a straight chain, typically speaking, the number is placed. Okay. But yeah, if you ever look for propanol, by the way, in propanol or propanol is how you'll typically find it, because the manufacturers are lazy, I guess. I don't whatever. Anyways, so the alkenes and alkynes, of course, remember that the enes and ines, these go where the ane would be, right? And so they're actually part of the root. They're not actually part of the suffix. Okay. So the E from the normal ene or ine root is going to be dropped. You're going to then replace that with, say, ol for alcohol, ol for alcohol, or amine for the amines, right? Locator number is going to be used when necessary. The highest priority functional group is given the lowest possible number. Notice that the suffix actually takes priority over the double bond. Okay? So for example, here we have the amine, right? And where is our numbering starting? With the amine, isn't it? Yeah. And then we give lower numberings to the ene, the double bond, right? We only indicate the first number in that double bond series, so we end up with 2. Everybody okay with that so far? Okay, fantastic. Anybody have any questions? Nope. Okay. All right, so let's look at one where we have an OH and amine at the same time, alcohol and amine. The highest priority functional group is again going to receive both the suffix and the lowest possible locator number. The other ones are going to be given prefixes listed alphabetically, just like before. You will use di, tri, tetra, whatever, however many you have. Prefixes when they are necessary. And so, for example, here we have diamino and a dichloro, right? This is cyclohexanol. Okay. All right. So, naming them with 2 or more highest priority functional groups. So again, you're going to keep the E in this case, and that's because we need vowels to connect non-vowels, don't we? That's just how English works. It's weird like that. And we're going to add the multiplying prefix for your highest priority group. So for example, we have 2 alcohols, that would be dial, right? Okay. Or 3 amines, that would be triamine. If you have multiple locator numbers, you'll put multiple locator numbers in front of that suffix. Okay. Anybody have any questions of those? Okay. How do I determine which numbers to give for those? Yeah, I give the lowest possible numbers just like I would any other case, okay? So I'm going to minimize my numbers as much as I can. Okay. Note that when you have multiple suffix ones, your numbering locators gets locked in real fast. Okay? It becomes a non-question very, very soon. Okay, I'm going to make you name something, so please join me. I know I'm flipping through these Q&A slides a lot where I just don't say anything about them. In case you're wondering, if you join the Slido classroom, you can actually put questions and it would show up on here without showing who it is. And I'd be able to like go, oh, okay, this is something somebody wanted to hear about and say it. Okay. All right, so what is the IUPAC name for this compound here? And can everybody appreciate? There's a picture there. Hopefully you appreciate it because it's $7 a month. So, ooh, ah. I'll point out that costs more than HBO. Was it worth it? Yeah. Okay. Better than HBO? Better than half of Netflix? Yeah. Okay. I know it's definitely better than Disney Plus, so. Is it? Oh my goodness. Whoa. Whoa. Well, it's definitely a hell of a lot better than, geez, it's over 3 times. Whoa. Okay, I'm going to be moving forward, so please make a guess so you can get attendance, if nothing else. I will note that in multiple choice questions, you may need to work things out on the page. And in multiple choice questions, you don't actually have to get to the final answer, do you? All you need to get is enough to be able to subdivide the answers. Okay? Okay, so I'm going to move forward. And we got 88% is this, and that is correct. Good job. And so, what was the highest priority group again? Alcohols, yeah. You got it. And so we have 2 of them. That's going to end up being a diol, right? In this case, we have a double bond, don't we? And how many carbons do we have in our longest chain? Okay. Ooh, I complicated it, didn't I? Yeah, so it actually doesn't particularly matter which is our longest chain here, does it? The reason for that is we're actually stuck. We have to take this chain, don't we? Okay? And that's because of the suffixes. So we got the double bond on that chain. We have the OHs. And that sticks us with that being the root. Okay? All right, so we have diol for our suffix. We have this chain, which is going to be 6 carbons long for our root. That root has an ene because of the double bond, right? Very good at that part so far? Okay. And the next part of this is we have an amine, don't we? And then we finally have this group right here. And so we are going to add an amine to the prefixes. We also have to add this complex group, don't we? And we get complex groups, those are going to require a parentheses around them. What sort of complex group is that, by the way? How many carbons is in this chain here? 3. And then it has one other carbon off it, doesn't it? Okay? And so that would be methylpropyl, right? Okay. We then need to take our locators. Honestly, because it's a multiple choice, we actually don't need to go through all the locators and figure that out, because we actually have enough to figure this problem out. But if it wasn't a multiple choice, we have to go, well, this is a 2-methyl. One would be here, right? This would be the second one. Okay. And so that complex group is going to be 2-methylpropyl. Now we need to organize them in terms of alphabetical order, right? And so A comes before all the others, doesn't it? So our amino is the first one alphabetically in prefixes. Then we're going to have a 2-methylpropyl. Then we're going to have the root, which is the hex. It has the 5th position, which is the ene, so 5-ene. And then the dials are on the 1st and 4th positions. Everybody okay with that? Okay, so let's talk about primary, secondary, tertiaries. All right, so if you can have multiple things that are bonded to a central item, like a carbon or an amine, then you're just going to count the number of chains that are bonded to it. Okay? So for this right here, we have a primary amine. It has one alkyl group bonded to it. Everybody good with that so far? Secondary is going to have how many alkyl groups bonded to it? 2. You got it. Tertiary is? 3. And that's the exact same thing as the carbons and carbocations were before, right? Yeah, literally just the number of carbon chains that are bonded to it. Okay. And so whenever we're doing this, the locator is going to end up being an italic N. What do you think that italic N stands for? Nitrogen. It means I'm attached to the nitrogen. Okay? And so that's what you'll be using. You'll put an italic N to establish that that group, that prefix, is attached to the nitrogen. And so right here, for example, we have this 6-membered ring. It has a double bond in it, right? And an amine on it. This methyl here is attached to the nitrogen. Can everybody see it okay? Fantastic. Okay. So let's go ahead and look at this other one. So here we have, again, this 5-membered chain right here. It has an amine on it. And it has, that amine has an ethyl and a methyl. Can everybody see that okay? Okay. And so this is going to end up being N-ethyl, N-methyl. Now there is another methyl down here, which is the 3, right? So N3-dimethyl. Okay. Okay. Mm-hmm.
So you, before the dimethyl, you put...
Yep, N and 3.
So another N. Okay.
Yeah. And that's this methyl right here.
Yeah.
And then this methyl is the 3.
Okay.
Okay.
If it was on the 3rd, that methyl on 3, would that change how you put the N or not?
What do you mean?
Oh, wait, never mind.
Yeah. So the
Then it would be
N is you have one methyl on the N, and that is why it's one of them is an N for the locator. If you ended up having more amines, by the way, if you had 2 amines and they had things on them, they'd be the N with the locator number, and then the next one. Okay. And you just put that right there in 1 and 2.
So you still
That's
give
it.
the second methyl the N, even though it's not attached directly to the nitrogen?
It is right here.
Yeah, that's not what I mean, but
Mhm.
okay.
Oh, no. The second one, the N is this one. The
Yeah.
other methyl is 3.
I'm talking about why do you give that one an N too, though?
It's not attached. It doesn't have an N.
It says N, comma 3 dimethyl.
Yeah. So we're saying normally you would put like 1, and if there's another one attached to one position, you'd put another 1, and then you put 3 for the next methyl. That'd be 3 methyls, right?
Right.
So each methyl has their own locator. One methyl has the locator that's N.
Yeah, I get that part.
Yeah.
So why
That
do we
N
put
has
this in?
nothing to do with the second methyl then.
So why do we put it there?
If there were 2 methyls on this nitrogen, let's say we had something like this, okay? 2 methyls. Okay? And then this is whatever, I don't care.
Right.
Okay, we would put N dash.
Okay.
Because each methyl has to have their own locator number. So that second methyl doesn't have anything to do with that N in front of it. That N has already been used on that first methyl. Okay? And the 3 has nothing to do with the first methyl, right?
Right.
Yeah. That making sense?
I think so.
Okay. Yeah. Each single one of those, like a dimethyl, each will have their own locator numbers. They don't have anything to do with the other one. Okay? Yeah. And this is because they're replaceable. Doesn't matter which one's, which methyl. Yeah. So you just need to say N, 3, 3, 4, 5, and then we have, how many methyls. Okay, so the ketones and aldehydes, these contain what's called a carbonyl group. That's that C double bond oxygen here. And in fact, we can actually write these basically the same way. Where in the case of a ketone, we have 2 carbon chains here. In the case of an aldehyde, we have a carbon chain here, or a hydrogen, it doesn't really matter. And the other one's a hydrogen only. And that's what makes that the aldehyde. When we're requiring a suffix when naming, the ketone is the -one, the aldehyde is the -al for the aldehyde. All right, and so these are some different examples. This, by the way, is acetone, that stuff we like using in lab. Yeah, or for paint removal, right? This one right here is going to be the, again, a ketone. This one's the pentanone. If you have multiple of them, this is the dione, trione, just like before. Anybody have any questions about those? No? Okay. Okay, let's talk about naming the aldehydes. You never require a locator number for the aldehydes. Can anybody tell me why that would be? If you have one aldehyde, you never require a locator. You never require into that? Yeah, it's always at the end. Because it has one that's a hydrogen, right? It always has to be the beginning or the end, right? And so if you only have one, it's at the beginning. That's number 1. If you have 2 of them, it's the beginning and the end, isn't it? Yeah. Done. Uh-huh.
Would that second one, wouldn't that be, so there is a ketone and an aldehyde.
There is.
So, it's 3, the oxo is,
This one.
the oxo is the ketone?
Mm-hmm.
Okay.
Yep.
That's the,
And the aldehyde is 1.
prefix?
Yeah, this is the prefix for ketone or aldehyde, actually. Because it doesn't really matter if they're the prefixes. And this is why the prefix, it doesn't matter, is because they have very similar priorities. And so if you have something higher priority than one, it's higher priority than the other as well. And your numbering is going to go off of that, right? Yeah. And so everything else, these ketones and aldehydes are going to end up being numbered off and just oxo for carbonyl. Yeah. Okay. And so any other questions on the naming for the aldehyde ketones? Okay. Okay. Mm-hmm.
That last one,
Mm-hmm.
is aldehyde spelled out, it's not just the suffix, the al?
Yeah, this is actually because it's off here.
Okay.
So this is not actually a ketone, which would be in the ring.
Yeah.
Yeah, so you actually have here a different functional group, slightly different functional group, which is the carbaldehyde. And it's an interesting example to put up here, but yeah. Okay. It's time. Okay. You all have a great day. I'll see you Wednesday. And we will start off next We'll do some acids. Oh, me being in organic chemistry and saying we're going to do acid sounds really bad. Hopefully nobody takes that one out of context, huh?